Good afternoon, ladies and gentlemen. We're back once again with another amazing science tutorial video. I'm Coach Spivey, joined with my son Jordan Spivey, and in this video we're going to be going over electricity and magnetism one-on-one. So let's begin. Let's start off first by understanding that electromagnetic force is the force created by electrically charged particles and magnetic force resulting from the movement of electrons in an atom. And both parts of electromagnetic force are caused by electric charges. And Hans Christian Ørsted, this man in this picture right here, discovered in 1820 that if you run an electric current through a wire, it will create a magnetic field. This was the first discovery of the relationship between electricity and magnetism. Ørsted discovered that moving electric charges will create a magnetic field around a straight wire carrying an electric current. So let's take a look at this. So if we look at this diagram at the bottom, notice here's this current going into the wire. And as this current goes through this wire and out of this wire, notice that it induces or it creates a magnetic field around the wire. And also it was discovered that if you was to make an electromagnet and bring it close enough to a compass, then it would actually cause the needle on the compass to move. So this is a further understanding of the relationship between electricity and magnetism. And now let's look at controlling electromagnetism. And we'll first start off with a solenoid. And a solenoid is a coil of current carrying wire that produces a magnetic field. And the more coils there are, then the stronger the magnetic field, and vice versa. So if we take a look at this solenoid to the right, and I'll go ahead and label it. Notice how many coils of wire there are. And notice how tightly packed or how close they are together. Remember, the more coils of wire there are, the larger the magnetic field. So now we have this electric current going in this solenoid right here. And since these coils are so tightly packed and there are so many of them, it creates a larger magnetic field around it. So I don't know if you can see, but here's the north pole or the north end of this magnetic field. And then here's the south pole or the south end of this magnetic field as the electric current goes out of this wire. Now let's take a look at an electromagnet. An electromagnet is a type of magnet in which the magnetic field is produced by an electric current, which usually comes from a power source like a battery. And unlike a permanent magnet, you can turn an electromagnet on and off by removing the electric current. And the strength of an electromagnet can be increased by the amount of current flowing through it, which can be changed by, you can either A, increase the number of loops in the coil. Remember, the more loops you have or the more coils that you add, the stronger the electromagnet. And then you can also get a larger battery or a larger voltage source. Then you can also use a nail with a soft iron core. And the reason why you want to use a nail with a soft iron core is because it carries electric current very well. So now let's take a look at our electromagnet right over here to the right. Notice you have some very simple components, or very few components that you need for it. So you would need a battery, you would need a wire, and you will also need a nail. And if you notice, if you wrap this wire around this nail and then connect it to the battery, you're going to have this electric current travel from the north end to the south end. And as it travels from the north to the south end, it's going to create a magnetic field around this electromagnet, which should be able to allow you to pick up objects that are attracted to magnets. Now if we look at electromagnetic devices, they're devices that convert electrical energy into kinetic or mechanical energy, which is basically energy in motion. And there are many electromagnetic devices, and some examples of them would include electric motors, doorbells, stereo speakers, headphones, tape recorders, MRI machines, telephones, toasters, and TVs. And remember, once again, the key advantage of electromagnetic devices is that they can be turned on and off by removing the electric current. So if we look at all of these devices in the background, this picture in the background, all of them require some type of battery or voltage source, whether they have to be plugged in or they have batteries directly. And remember, once again, you can turn all of these items on and off. And that's a key advantage of electromagnetic devices. Now let's look at how to build an electromagnet. And the materials you're going to need for it is going to be an iron nail. Remember, an iron nail with a soft core preferably. And 12 inches of thin insulated copper wire, metal paper clips, a 6-volt battery, electric tape, and scissors or sandpaper. And the first thing we're going to do is wrap the coil of wire around the nail approximately 20 times. Remember, we want to get some nice tight wraps. And you want to make sure to leave 5 centimeters of coil free on each side so we can shave that with the sandpaper and then connect the end to the battery. And step 2, you're going to use scissors or sandpaper to remove the insulation from each end of the wire. And then step 3, you're going to tape each end of the wire to the ends of the battery with the electric tape. Step 4, basically you're done. You have just created an electromagnet. So now you can hold the electromagnet by the battery ends and see how many paper clips you can pick up with the coil wrapped around the nail ends. And the reason why you're able to pick up these paper clips is, remember, an electric current going through a wire induces a magnetic field around it, and so you should be able to pick up these metal paper clips with it. Time for your check for understanding, and you're going to use your knowledge of the relationship between electricity and magnetism to answer the following questions below. You can go ahead and pause the video now. Ladies and gentlemen, I hope this video tutorial on electricity and magnetism was beneficial and helpful. I'm Coach Spivey, signing off with my son Jordan Spivey. And remember, I want you to have a wonderful, awesome, positive day. Ladies and gentlemen, have an awesome day. Peace.